Hello everybody, welcome back to another episode of Rethink Connectivity. My name's Jeremy, and today we're going to be diving into how to configure a JetStream stream. Now, there are actually two configuration options for JetStream. One is being able to configure the stream, and second is being able to configure the consumer. In a follow-up video, we will cover what it looks like to configure a consumer, because that's also in depth. Today, we're going to be focusing just on how to configure a stream. And one of the really neat things about JetStream in general is that you kind of have this single primitive, like a stream, and you can model it in a way and configure it in a way where you can have multiple different kind of patterns supported, multiple distributed systems patterns. And this is where a lot of the power of JetStream comes from, because you have the ability to replace a whole swath of different tools, whether it's like a distributed queue or a key value store or an object store or like an append only log. There's a lot of different patterns that you can essentially express within a JetStream stream. And so today we're going to be going over all the configuration options, because in the previous episode we took a look at those and there's a lot of them. We're going to be going through pretty much all of them today. And I'll be explaining some use cases, some best practices, and we'll be off to the races. So let's just dive in and get started. So first and foremost, let's jump over to some code. I'm going to be writing a little bit of Go, and this is just to kind of show you the examples of like all the different configuration options in code. But you can also create any of this in the CLI with a NATS JetStream create command, and you can see that I'm allowed to create my stream. I'm going to go ahead and say, give me the help for this. You have all the options available to you here within the NATS CLI, which is great. You also, if you are using or following along using Synadia Cloud, which by the way, you can sign up for free, you can go over to Streams and you could hit Create Stream, and you have a lot of these options available to you here, things like name, description, subject, and we're going to dive into more of these options that you see here and what they all do. And so today we're going to jump in and we're going to actually create it. We're going to look at these stream options via Go, just so if you're creating a stream inside one of the client libraries, you can kind of follow along there. So let's go ahead and fire up a Go file. I'm just going to name this package main and func main, and I'm just going to write a little bit of easy code here. Let's create our NATS connection, which will be nats.connect, and we'll just use the default URL for now. Let's go ahead and import NATS, and we will handle our error. We'll just say log.fatal for that error if it errored out. Let's import that. And then secondly, we want to use the new JetStream API to be able to create this stream. So I'm going to say JS and error equals jetstream.new. There we go. Let's go ahead and import that, and we'll handle the error. And now that we have a JetStream, we can now easily create our stream. So we're going to say create stream. And just like in our previous video, the new JetStream API takes a context as its first argument, which is great. So I'm just going to say context.background here. And its second argument is going to be a stream config. And so we're just going to go ahead and say JetStream stream config. And I'm going to go tell my NeoVim to go create all of these. So as you can see, this is a lot of options here. So let's walk through this step by step, and I have a little bit of drawing as well to kind of illustrate how a lot of these concepts work, because a lot of these options actually combine together in some interesting ways, and this is what kind of allows for the expressiveness of the system. And this can be a little bit overwhelming at first, and it can be hard to kind of figure out, okay, what option does what, or what do I need to use in certain scenarios. And so this is kind of a really good primer for learning how all of these options work. So let's just start with the very basic ones, which would be name, description, subjects, and I even throw something like storage in here. These are kind of your primary bread and butter. Every single stream will need to know or utilize most of these. Your name, for the stream makes a lot of sense. It's basically the identifier for identifying your stream, for creating consumers from that stream, et cetera, et cetera. You look up the stream via the name. And so that's an important little bit. Description isn't really used in any kind of like infrastructure portion or any kind of like inner machinery for JetStream, but it's a good kind of human readable description of what the stream does, and that will show up inside of the NATS CLI, like over here, I could say NATS stream list, and you can see I get an orders stream with a description there. So great for monitoring, great for kind of just, having a human readable description there. Secondly, or thirdly, actually, we have subjects. And in our previous episode, we kind of went over subjects, that you could have multiple subjects, that you could say something like orders.star. So you can use wildcards here. You can also just layer on, hello.world. You can have multiple subjects that the stream is essentially slurping up from core NATs and persisting onto disk, which is great. Lastly is storage, and from here you can pick either a file store or a memory store, with the obvious difference being that the messages in memory are going to be stored in memory, and therefore they're kind of ephemeral. If the NAT server goes offline, those messages are going to be lost. So memory store is a little bit more niche, because I think for the most part, when you're using JetStream, you want to try to keep those messages persisted. But they're great for things like caches or things that really don't have a fast disk write performance or anything like that. And we'll talk a little bit about how we could use caches and things like that with sourcing and mirroring. And where we might want to use a memory store in some cases. So those are the basics. But then we're going to be getting into some really other interesting sets of options, and we'll keep this open to kind of follow along. But then I'm going to pull up my drawings, and we're going to just cover some of these in some categories that I put together. So let's go ahead and do that. So heading on over to my drawing. The first kind of category that you're going to want to be aware of is this idea of limits. And limits is a really important aspect to JetStream, specifically because limits drives a lot of behavior inside of the stream. And being able to configure these limits in certain ways can really radically change how things get persisted to disk, and what the retention and discard policy looks like for this. And so here are a couple, different instances of limits that you can configure. You can configure the maximum amount of messages inside of a stream. Maybe I only want 1,000 messages in this stream. You can configure the maximum amount of bytes, which is super useful. And in some cases, if you're using Synadia Cloud, it's actually required. You want to be able to put an upper limit on the amount of messages that are stored inside of this stream. More interestingly, you could also set a max age, saying that every message that goes into the stream has a particular time to live, or TTL, and that messages will then start getting discarded once they hit that age, which is again great for things like caches that you need to keep hot, or things that are just a little bit more time aware, or things where you might have a retention policy of 30 days or 365 days, and you can naturally let those messages fall off. The other interesting thing, and we talked about this inside of our previous video, is that in JetStream, the streams actually index all of these messages by subject. And so another kind of interesting bit on limits is that you could say, I want a certain amount of max messages per subject. And you could, for instance, set that to 1 if you literally just want the last message per subject persisted onto disk, or you could set that to 5 or 3. And this is actually in use inside of our key value store, where you can set a history, and max messages per subject is the driver of that. You can also say, here's the max message size, and here's the maximum number of consumers on my stream. And so this is kind of your baseline of you can choose to combine each or any of these in whatever way possible, and the rest of the system is going to kind of adapt to those limits that you put on there. Kind of moving on to another related set of systems to limits is your retention and your discard policies. And so this can be a kind of a confusing bit for people when they first get started with JetStream, because this is the overwhelming part, is what do I do for my retention policy? Well, for the most part, you can keep it at the default, which is limits, and it's going to mostly perform the way that you want it to. But it's worth knowing what the other retention policies are, because they can be really, really useful depending on the type of pattern that you want to support. And so let's first talk about the limits retention policy. I think the limits retention policy is kind of like the most basic and intuitive, and then all the other retention policies kind of build on that. And so the way the limits policy works is, when a new message goes onto the stream and it's hit a limit in a certain way, whether it's hit that, max messages per subject, or the max bytes for the stream, or the max messages per stream, it's going to start, invoking the discard policy. Now, in this particular circumstance, we're going to assume that this is the discard old policy, which means that when a new message comes in, like sequence number 6 here. And if I only have, a max message amount of 5 in this stream, then it's going to start deleting the older messages to make sure that the stream stays within those limits. And again, this is a really powerful construct because it means we can keep our streams very tight, and we can put some good limits around it and make sure that things are getting cleaned up and discarded along the way. Building on top of that is something a little bit more interesting, which is the interest policy. And the interest policy is kind of a subset, or I guess a superset of the limits policy, meaning that it does everything that the limits policy does. It still keeps everything to its limits. But in addition, it will delete messages once they have been consumed by every consumer that's interested in it. Meaning if I have a consumer and it's interested in that message, meaning it hasn't filtered it out, or it's alive and belongs to the stream, the interest policy is going to delete any messages that have been acknowledged by all the consumers that are interested in it. And this is great if you have kind of multiple consumers and they're all kind of like picking off different messages for different reasons, but you really don't care about the persistence of the message after it's been processed. Maybe it's some type of fancy work queue or something like that. This is where you'd want to use kind of the interest, is if you have kind of multiple consumers that are using or listening for messages for different reasons, but you also want to keep this acting very much like a queue where something goes in, it gets processed, and it gets deleted. Even more specific to that is the work queue policy. So the work queue policy functions very much the same as the interest policy, except you don't have multiple consumers. Instead, you're restricted to actually only have one consumer for the work queue. Now, if you remember in our last video, a consumer can actually share multiple clients. So you don't have to think that, oh, just because I have one consumer, it means I can't load balance between them, because that's actually not true. Instead, a work queue acts just like that, where you have a stream and you have one consumer on it, you have multiple clients consuming from that queue, and as soon as the message gets processed, it gets deleted. And so this keeps a really kind of tight, focused retention policy for those messages. Works very similar to like a RabbitMQ or any other kind of durable queue system that you're used to working with. And can just be a really, really nice way to have that kind of queue functionality inside of JetStream. And so that's kind of the high-level overview of what the retention policy looks like. But let's go ahead, because we assumed as we talked about this that the discard policy was discard old, but there's actually another discard policy that we should talk about. So discard policy is another set of options that basically allows you to configure what you want to do when you've hit a particular limit. Do you want to discard the older message, or do you want to reject any newer messages that come in? And this can be really useful because you might want to have a stream where it just naturally lets older messages fall off, or you have a stream where you absolutely do not want to lose data and you would rather start rejecting API calls in order to not lose data when you've hit those limits. And so that's a decision that obviously depends on the use case that you're going for, but discard new is an option here, meaning it's going, once it hits that limit, whether it's a number of messages or a number of bytes for the stream, it's going to start rejecting API calls or publishes to that stream until the limit is lifted or the limit is changed or the condition is changed in any sort of way. So that's useful to know as well. You might want to look at what you configure your discard policy to. By default, it is discard old. So those are kind of the higher level things that drive a lot of the functionality inside of how we persist things into our JetStream. But let's talk about a couple other little options. So there's one called duplication. Now, by default, this duplicate window is going to be 2 minutes. And JetStream automatically does deduplication for messages in your stream as long as you include a header inside of your messages, this NAT message ID header. And the way it works is there's a sliding window, like I said, by default 2 minutes, which you can configure to whatever you want. that will allow or will naturally deduplicate messages that share the same NATS message ID. And this is great kind of just hygiene in the distributed systems world where plenty of things can go wrong and clients can shut down or retry or whatever. And you want JetStream to kind of just manage all of that deduplication for you. All you need to do is stick that header inside of all your messages and we'll start deduplicating, and you can configure that window however you'd like. So that's deduplication. Let's move on to another topic, which is republishing. So republishing is super fun. And this is kind of a recent feature in NATS JetStream. I think it was maybe launched about a year ago. But republishing is really, really great for, so consumers, they are pretty lightweight, but they still have a cost to them. And once you get into like the use case where you might need like millions of consumers, all of the machinery of consumers might not be worth the added cost of hardware, of, you're ballooning your NATS cluster, anything like that. And so if you're willing to trade kind of the kind of persistence around consumers, that kind of temporal decoupling, you can actually get a lot more performance by having that message that gets saved to disk essentially send a notification, have the stream send a notification whenever a message gets persisted to disk. And so when you configure, for instance, a republish and you say, I want everything that's like hello Jeremy to be republished to monitor.jeremy and only include the headers, that's one other option that you can do. What that's going to do is anything that matches that particular source is going to be republished under core NATS. And so this is great for things like monitoring and logging and all kinds of other stuff that might not be mission critical in terms of I need to have a consumer that's kind of keeping track of all of this stuff, but instead just wants to listen via core NATS for a notification when something's been saved. Because you can configure headers only, you could also make this very, very performant over the wire where it's just sending the bare minimum that's needed. So republish is a really, really good option for you if you want to create some sort of monitor or something to kind of watch the stream. You can also do that. All right, moving on. Let's talk a little bit about replication. So replication is a super important aspect of JetStream, and it's actually one of the things that is like the big value prop essentially for JetStream is that you can place all of these NAT servers everywhere, and then you could have your microservices and your data kind of like move around and be nomadic, and JetStream tries to continue to work in that similar way. But one of the problems is that data has to live somewhere. Like that's the big constraint, right? So we can't necessarily just say like place something and have it just magically replicate everywhere because, we have to abide by the laws of physics. And so if we want to implement something like raft consensus and we want to, be immediately consistent, then we have to have a system that kind of supports that. So the way JetStream works in terms of replication is we have a couple different layers of replication. And the one that I'm going to talk about right now is kind of your replication factor. So your replication factor is the ability to say, hey, I'm going to put this stream, on this cluster, and then I want to replicate it X number of times. And JetStream is going to try to figure out based on how many nodes are in that cluster, whether or not it can replicate it that many times. But this is for reliability and resilience, right? Just like we talked about before with JetStream and its kind of resilience components and replication factor, you're going to want to use multiples of like 3, 5, 7, depending on kind of the nodes that you have and what your plan for resilience is. But that way, because we use the raft consensus protocol to basically replicate all of these things, with a replication factor of 3, you can manage to have, one node offline and still handle writes, 2 nodes offline and still handle reads. And that kind of extends to, the rest of the kind of replication factors as a rule of thumb. So I can set my replication factor, by default it's 1, but I could set it to any number that I want, and these will be, replicated amongst the nodes inside the cluster, and they will be immediately consistent. And so that's something to keep in mind. Now, I can't go outside the cluster with this version of replication. They have to remain inside of the cluster, and that's a very important kind of distinction. Now, placement is a set of options that is very similar to or plays alongside replication, which is like, where do you want your stream to live? And when you're working in a much more connected kind of NATS environment where you have multiple clusters, maybe you're operating on a supercluster, you're going to want to have control over where that stream lives. Do you want to place it on US West 1? Well, you can specify a cluster for that. Additionally, you can also specify tags. And so every single server has the ability to have tags configured for it. And so we recommend when you're building a NAT supercluster that you tag things appropriately. So you can say, this is US West, it's in AWS, and maybe there's SSDs here, right? And that way, when somebody goes to kind of create a stream, they can specify the tags that they need, and essentially the NAT server will figure out what affinity it needs to be able to place that stream. And so this is a really, again, important distinction is you can use tags to kind of drive, very large arbitrary clusters and make sure you pinpoint exactly where your stream will live. Moving on to another set of replication, which is mirroring and sourcing. If you want to go outside of your cluster for replication, then you need to start looking to mirrors or sources. And mirrors and sources are very similar in a lot of ways, but there's a couple of really important distinctions. And so the way you can think of a mirror is that I have a stream in one cluster, and I want to just basically mirror or have a one-to-one digital twin of that stream in another cluster. Maybe I have a bunch of consumers that are trying to consume from this stream, and or trying to get information from this stream, and they want to have really good latency performance as they're doing so. Rather than them kind of ping-ponging back and forth, from this US West cluster, we can create a mirror of that stream in the US East cluster. Now, the important distinction for a mirror is that it's replicated across cluster, and that all reads will be served from this mirror, but that all writes will actually be forwarded to the source or the original stream that is being mirrored. And that's an important factor because we need to maintain consistency across this kind of like global deployment. Now, that's enough about mirrors. Let's talk about sources. So sources are kind of similar to mirrors, but it's a little bit like the other way around, where I can create a stream and I could say I want the data in this stream to be sourced from other streams. And I can essentially aggregate a lot of streams, and I can filter on these streams. I can do a lot of things. I can even still have subjects that I'm ingesting on the stream that play alongside these other streams. And so maybe you have a leaf node deployment at the edge where you have a bunch of streams and you want to aggregate them all into one mega stream in the cloud. That's a really good use case for being able to source streams, is aggregating all of those. Now, the biggest difference is that it's not a one-to-one mapping of these streams because we're kind of mixing and matching. So sequence IDs are going to be, unique and different, specifically unique to this stream. Instead of being a one-to-one mirror, it's actually going to be a brand new stream, but with just, messages from the other streams in there. And so there's different use cases for where you would want to use a mirror versus where you would want to use a source. And we're going to go a lot more in depth into how to configure these, how to manage them at scale in a future video. The last kind of set of features that we want to cover here is the more advanced features, which some of these we'll cover in follow-up videos, and some of them we'll just kind of glaze over because they're, they're more niche features. And if we want to create a video off of them, maybe someday we will. But the first one is compression. This one's more self-explanatory. You could turn on compression. It's only limited to the file-based stores of streams. It won't. We won't let you do it on in-memory stores, but that's useful if you need to compress your data or your data is highly compressible, so it's beneficial to do so to kind of save disk space. The next one is allow rollup, and this is an interesting feature and maybe warrants a separate video. But basically, what allow rollup allows you to do is if you pass a kind of a special header, it will either roll up the entire stream or roll up a particular subject. And what I mean by roll up is it will persist that message that just came through and it will delete everything before it. So this is great for data stores which are either derived or could be computed or could be collated in some way, shape, or form. And it's a very kind of efficient way to be able to kind of like, make a calculated, version of all the rest of these messages before it and just kind of clean up the rest of the stream. So really, really great kind of little tool for that. Deny delete and deny purge are just kind of little flags that you can add to this stream to enforce that whether or not somebody can actually delete or purge messages. Deleting messages is being able to like pick out a particular message and delete it. Great for like GDPR purposes and things like that. Whereas purge is more kind of on either a subject or a stream level, basically going through and removing all of the messages on that stream or on that subject inside of a stream. Consumer limits are a way for you to configure default consumer limits for consumers that are created on this stream, and we'll dive into that more in the next video for consumers. And lastly, and this warrants a video all on its own, but subject transforms are a really, really neat way, and these are actually pretty new inside of the NATS server. Subject transforms for streams allow you to transform the message's subject before it gets saved to disk, which is super useful for, especially if you're kind of like aggregating a bunch of streams via this sourcing method. You can essentially transform the subject into something that might be a little bit more appropriate for the stream, the mega stream that we just described. And so that's kind of a high-level overview of all of the options. What I encourage you to do is just to jump into the NATS CLI and start playing. All of these options are available to you, and most all of them can be changed on the fly, which is actually a really cool thing when you think about it. Because if I say, NATS stream create, and I look at its help, you can kind of see that even things like placement, what cluster it lives on, things like that, those can also be changed, live while the stream is being used. And we actually take the stream, we replicate it, we move it in flight while consumers are consuming from it or things are publishing to it. It's really, really impressive. So many of these options for streams can be changed at runtime. And I recommend you just start playing with it. If you want to create a durable queue, let's play with creating a work queue based stream. Or if you want to create something with a bunch of limits around their subjects, go ahead and set those limits and poke at it and kind of get a feel for what it looks like. But that's a high-level overview of what it looks like to configure a stream and what all these options mean. Hopefully, by kind of seeing how all of these pieces fit together, you have a better mental model of what what a stream can be, and maybe even what options to use for your particular use case. But I'd love to hear feedback, so feel free to kind of comment below, ask kind of for what you'd like to see in future videos here. I do have a bunch queued up just on like NATS JetStream fundamentals, but I'd love to include some very specific things that you feel like is missing either from the documentation or from previous videos. So sound off in the comments. I'd love to hear it. And that pretty much does it for this video. So thanks so much for watching, and I'll see you in the next one.